of day Tuesday, and you should have an opinion formed about this. So we're going to talk it through before we go through what we need to today. So you should already have an opinion down on page 76 in your book, or you may have put it on CodeApp. But I want you to look and see what you thought. Who's the better golfer out of my cats? Those are literally my cats' names. Siegfried was too weird. He's white, so like a white tiger. Siegfried and Roy are the guys who had the white tigers. Siegfried was too weird, so we named him Roy. And Minerva, because she looks like Minerva McGonagall in cat form. Alright. We call her Minnie, because she's tiny. And I can put up videos of her later, because she walks different. She's a special kitty. All right, what do we think? Who's a better golfer? What do we think? Minerva, why?
Because she has higher points and her points are close together too.
Because her points were closer together? Like I say, I have our data on the graphs that we had it up here. So we've got Minerva. I could absolutely see the argument for it. She has a median of 78. She has some really low scores. I don't like that that's way off the edge like that. That's okay, I'll deal with it. Did anyone think Roy? I genuinely hate how off the screen that is. I'm going to get it so I actually see the data points. Because there are valid reasons to pick each one of them. And I'll talk through them both here. Because this is going to be one of those times where as long as you have reasons for what you picked, you're right. There's not one right answer here. There's different opinions. There we go. I'm going to put this over here. Yes, that's hand sanitizer. Boop. There we go. All right. If we look over here, now we can actually see. What might be a reason somebody might have picked Roy? He's more consistent. His standard deviation is about half of what Minerva's is. So his standard deviation is 4.7. So he is significantly more reliable. Minerva's got some real low scores, but she's also got a 95. So if she has a bad day, hers are significantly farther apart. So if you want to take that gamble for the low on when you're saying somebody's a better golfer, yeah, Minerva has some lower scores. Minerva has a lower mean, and why did it open maps? Go away. So Minerva has a lower median. Her center score is significantly lower. Their average is identical. Identical. They have the identical average. It's just that Minerva is significantly less reliable. She's got some higher, she's got some lower. So there are arguments to be made on both sides. Both are right. There's not one right answer always. Sometimes there is, but it's not always the case. If you have data to back up your opinion, rock on. Okay, so follow your data. Okay, so what we're really going to do today is we are going to be on page 77 and I believe 78 today in your book. I just wanted us to talk about that, and I didn't want to have to rush you through that on Tuesday. Yeah, we're going to do 77 and 78 today. So what I want you to do, and you are going to do this one by hand, find the mean and the median for this data set. Should take us like 2 minutes. Find our average. Most tables have at least a few calculators. Y'all have 4. There's all of them now. Oh, sorry, did not mean to throw that at your head. They usually have grippies on the back that slow their slide. That one does not. What's that? I got an answer. Yeah. Yeah. It's one of those that kind of auto-populates itself through, and the data had a little bit off. It's in here, definitely. So it'll still adjust. Utilize calculators. Use the tools you got. You can use your phone if you want to. Here. All right. What do we think? What's the mean on this data set? 41. I agree. Ooh, that's the wrong pen. What's that? Oh, it's just a fidget. So for people that are like foot bouncers, like they do this, that stops them from having the shoe squeak when they bounce their foot. Because that drives me a little bit nuts, but I'm also a fidgeter. But it stops you from getting the like tip of their foot. So it's just a fidget. All right, so if our mean is 41, what's our median here? Our median is not 10. That would be our low. Yeah, I was gonna say, because it should be like between these guys, right? Halfway between them, because they're in order. So the easiest way to find your median is to just work in from the outside. Everybody's in order here. So it's not 10 or 80. It's not 15 or 60. It's not 25 or 55. It's not 30 or 55. So it's halfway between 30 and 50. What is halfway between 30 and 50? 40. So our median is 40. It's the halfway point. It's halfway through when they're set in order. So let's look at part 2 now. What happens to our data if that 80 accidentally is at 800? So find the mean again and find your median. Oops, sorry. There we go. My iPad likes to be a jerk sometimes. All right, did we find the new mean? What was it? 113. So So our average is now 113. What's the median? 40. So when we have that one really big number, which one changed? The mean. So this is what we were talking about on Tuesday with that distracted boyfriend mean, that outlier. One really high value makes our mean go, ooh. And he gets very distracted and wanders off. So changing the 80 to the 800 pulls the mean. Towards, that's called an outlier, which is what we're going to be talking about today. We're going to be talking about outliers and how we can find them and how we can test for them. Pulls the mean towards the outlier. It does not affect our median. If we're changing a term, that outlier does not affect our median. It's still in the middle. If you think about a median being the concrete thing down the center of the road, it don't matter what's on that road. That sucker's still staying right in the middle. Okay, so this was just kind of giving us a numerical exhibition of distracted boyfriend. Chasing after that outlier. Which apparently I cannot do without doing this. Okay. So we can tell right here that this 800 is definitely an outlier. It pulled my mean really far. I mean, all my other numbers are between 10 and 60, and this one's way too big. We know that that's an outlier. But we're going to do a test today to figure out where exactly something switches from being just a big number to an actual outlier. And in order to do that, we're going to need to actually be able to construct our own box and whisker plot. So when we look at page 77, 70, whichever one, 8, that one, we're going to use this data to construct a box and whisker plot so that we can find out if there are outliers. We have to construct the box and whisker plot in order to be able to find out if there's outliers. So there's a blank at the top of your page, and from the words that I have said about 12 times already today, we can probably fill in what's in the blank. An outlier is any data point that is that specific amount from the upper and lower quartiles, which genuinely doesn't make sense. But what we're talking about today is an outlier. And we're going to talk about how to test for an outlier using a box and whisker plot. So that's what we're going to make. We're given this data set. 39, 51, 36, 39, 90, 55, 32, 61, blah, 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 blah. And the first thing we need to do is to construct a box and whisker plot, which means I need these numbers. This is called a 5-number summary. I need the minimum, I need the maximum, I need the median. If I know I need the median, I need these guys in order. I need to put my data set in order. Smallest to biggest or biggest to smallest, I don't care. I tend to do smallest to biggest because number lines and math person. But that's me. As long as they're in an order, I don't really care which way you do it. So we're going to put them in numerical order. And I'm going to do it just right next to my data set up here. I'm just stop it so you guys don't keep having to zoom into me. And you guys have space like next to your data set or in that big space on the right or at the space at the bottom of the page. Or even you can use the space at the bottom of the next page because we won't need that space as much. But so we're going to set this up in biggest to smallest order or smallest to biggest order. I'm going to do smallest to biggest. So I'm going to have 14. That's the smallest one. The next smallest is 32. So there. My next smallest is 36. So I've used that one. Then I have 39. And I have another 39. So I'll put those next to each other. Then I have 45. So you see what we're doing here. We're just putting them in numerical order. I've got to give myself some more space over here, so we're going to color over this purple part just so I can write there. There we go. So above the 45, we have 51 is my next one. Then we're going to have 53. 55. 61 and 90. And that's all my data points. I tend to, when I'm having to put them in order, I will cross them out just like that so I can make sure that I get everybody and that I don't skip anybody. So then what I'm going to do is I'm going to ask you the median. Where's our median? Once you have them in order, you can use your fingers to do this. I have to use my hands because it's big on screen. So, not those guys, not those guys, not those guys, not those guys, not those guys. Oh look, there's only one left. So what's our median? 45. And I'm gonna circle it as soon as I stop throwing stuff. I want purple that actually looks different than the black. There we go. So that is my median, 45. What's my minimum? 14. And what's my maximum? 90. This guy down here. So the weird thing on here is our lower quartile and our upper quartile. What we're going to do is we're going to take the numbers smaller than our median. So we're going to look at our data set that's over here. And we're going to find the median of just that piece. What's the median of just the smaller numbers?
45.
Just the smaller ones.
36.
36. That is called our lower quartile because it's lower than the median. It's the median of the what's left. Similar vibe, but for the numbers bigger than the median. What is our upper quartile? 55. It's the median of the higher. Let me mark the 36 there. These numbers right here are what we need in order to make a box and whisker plot. So I'm going to draw one out. We have our box and whisker. On the minimum, goes on the left, 14. Our maximum goes on the right. Our median is the line that kind of goes through the middle, is 45. We're going to put a little dash where our quarter 3 is, so our 55, and our 36. And if I connect my Q1 and my Q3, my lower quartile and my upper quartile, ta-da, box and whisker. That's how those are made. That's how those are built. If you go into CodeApp and you put this data set in and say make a box and whisker, it'll look just like this with those same points on those same values. So that's how we build those box and whiskers. We've looked at them before, we've seen them before. But we gotta be able to build it so that we can find the information. Because what we're gonna talk about today is one of those measures of spread that we've talked about. We've talked about standard deviation, bigger spread. Smaller standard deviation, smaller spread. Our other measure of spread that we did on that big vocab dump day, we talked about the inner quartile range. So what it is, it's a way to look at the spread on a box and whisker plot without looking at everybody. So we're going to look at the inner quartile range. And what that is how wide is the box? What is the difference between Q3 and Q1? How wide is that box? So what we're going to do is we're going to take those values, my 55, and I want to know what the difference is with Q1. Minus 36. What is 55 minus 36? 19. So our inner quartile range is 19. That means half the values are in this set of 19 numbers. That's half. Half everybody's right here. The way we check for outliers, and it's going to feel really arbitrary because it kind of is we're going to take that 19 times 1.5 times 1.5. So 19 times 1.5. What is 19 times 1.5? 28.5. The way we measure an outlier is I want to know, is it this many or more outside the box? So we're going to take Q1 and we're going to count down 28.5 from this side of the box. So that's what this line is saying. Q1 minus 28.5. So 36 minus 28.5. So 36 minus 28.5. What is 36 minus 28.5? $7.5. Are there any values in our data set that are 7.5 or smaller? No, 14 is as small as it goes. So what this means is we have no low outliers. There's no outliers that are super small numbers. So I need another color. What's up? Can you wait like 2 minutes because we got one line left to go and then we're done. Okay. So no low outliers. We're going to do the same thing the other direction with Q3. So I'm going to say my Q3 plus that 28.5 to see if we have any high outliers. So if we have 55 plus 28.5, what do we have? What is 55 plus 28.5? Yeah, 83.5. Do we have any data points higher than 83.5? Which one? 90. Which I totally just put that as the date on this prize. So this data set does have an outlier. 90 is an outlier. Because it is bigger than 83.5. Anything outside that 1.5 times the box is an outlier. And it feels really arbitrary because it kind of is. but it's one of those things that is how statisticians decided to test for outliers. There you go. I just didn't want you to miss that next slide. Okay. So there is a homework up on Canvas that has a link to a CODAP data set that asks you about outliers, that asks you about how to test for outliers, and we can look at that. That is homework 5. And again, it has a data set on CODAP. And you can have it show you the box and whisker plot. You can then get your data off of it. Let me pull it up real quick so you can see it. Alright, let me go like this. Alright. So, come on, screen, being a jerk. There we go. There we go, student view, because I don't want to give you guys secrets. Snap. So there's a link right here to the data set. It has the information. It's the same stuff, and this is in your book. This data set is in your guys' book. It's like 2 pages later. Page 80 has this data set, but you can also get it here, and it's going to open a CODAP link. It also has the questions here, so you could do the whole thing here. You can look at graphs, you can slide things around, you can put your speed somewhere, you could put something like this, you could get data here, you can put the lane on this side and it'll split it into 2 data sets. That might be helpful for something. You can look at this stuff and get your box and whisker plots. It's got the information, and if you hover your mouse over it, it'll give you the numbers so that you can calculate stuff. Okay? So it's all there. The CODAP is there to help you. All right? So use the stuff. Practice using the software because we're going to need it when it comes time for the project. All right, so that is what you're working on. You've got 15 minutes to the end of the period. Work on homework 5. I highly recommend.